All right, let's talk about a term you've probably heard a million times if you're in the tech world: NoSQL. It gets thrown around like it's the magic bullet for any big modern application, but what does it actually mean? Let's cut through the buzz and figure this thing out. Here's what we're going to cover. First, we'll bust the biggest myth about NoSQL. Then, we'll get into the real difference between it and traditional databases. Think tables versus blobs. We'll lay out the pros and cons, take a peek under the hood of a system like Cassandra, and then wrap it all up by figuring out when you should actually use it. So let's kick things off by tackling the number one reason people seem to reach for NoSQL in the first place: this idea of scalability. This is the first thing you hear, isn't it? You're planning something huge, you're expecting millions of users, so, obviously, you need NoSQL. It's almost an automatic reflex in the industry. But is that really the whole story? Yeah, not so fast. It's really not that simple. This is probably one of the biggest misunderstandings about NoSQL out there. The idea that if I need to scale, I need NoSQL is a total myth. And check this out. This really drives the point home. Some of the biggest, most ridiculously scaled apps in the world, we're talking YouTube, Stack Overflow, Instagram, they all run on good old-fashioned SQL databases. They just figured out clever ways to make them scale. So if it's not just about getting huge, what is the real dividing line? What's the fundamental difference? Okay, the real difference, the thing that truly defines NoSQL, has nothing to do with scale. It's all about how your data is actually shaped. It's a tale of two completely different philosophies: structured tables versus what you can think of as blobs. Here's the best way to think about it. A traditional SQL database is like a super organized filing cabinet. You've got one drawer for customer names, another for their addresses, and you use a little reference number to link them together. A NoSQL database, on the other hand, is more like a project box. For each customer, you just throw everything about them: their name, their address, their order history, all into one single box. It's all self-contained. Let's make this real. So in our SQL filing cabinet, we've got a users table. We can see John Doe, his ID, his age, but notice his address? It's just a number, address ID 23. To find out where he actually lives, we need to go look in a different drawer. And here's that other drawer, the addresses table. We use that ID 23 to find the right row. Now, to get the full picture of John Doe, the database has to do this little dance called a join, where it pieces together info from these two separate tables. It's very powerful, but it takes work. Now, contrast that with the NoSQL project box. Look at this. All of John Doe's information is in one single chunk of data, one blob. His address isn't a reference number somewhere else, it's just right there, nested inside his record. When you need John's info, you grab this one thing. No joins, no piecing anything together, it's all right there. And this one single design choice, storing everything in these self-contained blobs, is the source of everything. It's where all of NoSQL's biggest advantages come from, but it's also the source of all of its biggest weaknesses. It is a world of trade-offs. This table really sums it up perfectly. On the one hand, because everything for a user is in one blob, it's crazy fast to read or write their entire profile. That's called data locality. Awesome. But what about the flip side? Say you just want to find the average age of all your users. Well, now the database has to open up every single one of those project boxes just to pull out that one little piece of information. That can be really slow. You gain flexibility, but you lose the rigid, guaranteed relationships you get with SQL. It's a classic give and take. So we know NoSQL is built to be spread out across many machines, but how does it actually work? Let's get our hands a little dirty and look at a popular NoSQL database, Cassandra, to see these ideas in action. So when you write a piece of data to Cassandra, this little three-step dance happens instantly. First, the key for your data, like a user ID, gets run through something called a hash function. It just consistently turns that ID into a number. Second, that number determines exactly which server in your whole cluster gets to hold on to that data. This spreads the load out. And finally, for safety, that data is automatically copied to a couple of other servers too. And this is a perfect way to visualize how that distribution works. Imagine all your servers are arranged in a big circle, or a ring. Each server is responsible for a range of those hash numbers, a slice of the pie. The hash function's job is to make sure the data lands evenly all around the ring, so no single server gets overwhelmed. It's a really elegant way to balance the load. Now, that third step, replication, is the absolute secret sauce for making the system reliable. It's your insurance policy. By making copies of data on different machines, Cassandra guarantees that if one server just dies, your data is still safe somewhere else. It's also great for read performance because when you ask for data, any of the servers holding a copy can answer you. But wait a minute. What if the copies get out of sync? Or a server is down, like we see here? This is where a cool concept called quorum comes into play. It's literally like holding an election. For any read or write to be considered successful, a majority of the servers with that data have to agree. So here, server C is down. The system asks A and B what the answer is. They both agree, so the vote passes. It's like democracy for your data, ensuring things stay consistent even when the system is messy. And finally, how does Cassandra write things so darn fast? Well, the trick is it kind of cheats. It does the easy part first. When new data comes in, it just scribbles it down really quickly in memory, which is super fast. Think of it like a messy notepad. Then, later, when it has a free moment, it neatly organizes those notes into permanent, sorted files on the desk. Another process works in the background, like a janitor, cleaning things up. The core idea is, accept the right now, make it pretty later. That's the key to its speed. Okay, so we've busted the big myth, we've seen how the whole blob model works, and we've peeked under the hood. All of this brings us to the most important question of all. When should you actually use NoSQL? NoSQL really starts to become the right tool for the job when a few things are true. First, if your data just feels more like a project box than a filing cabinet, think user profiles, product catalog entries, IoT sensor readings. It's also great when you have a massive amount of writes coming in all the time. And, crucially, it's for situations where you care more about your application always being online and available, even if it means the data might be slightly out of date for a split second. So you see, in the end, it's not about which one is better. It's never been a fight of SQL versus NoSQL. It's about trade-offs. The question you always have to ask yourself is, what does my application really need? Do I need the bulletproof, rigid guarantees of that filing cabinet? Or do I need the raw speed, flexibility, and scale of a whole warehouse full of project boxes? The right answer depends entirely on the problem you're trying to solve.